Well, welcome to the first of this afternoon's sessions on BIM and GIS for landscape. Myself, I'm Product Director Mike Shilton at Keysoft Solutions. I'm also the chair of what is now called the Landscape Institute Digital Practice Group, formerly the BIM Working Group. Joined with me today is Martyn Horne from as Development or Product Development Manager at Vectorworks Landmark. He's also head of the technology work stream for the BIM working group. And Darren Hickmott as well has joined us. So we're doing a three-way presentation. And Darren's the BIM manager at Arup. He's also heading up, at the moment anyway, he might be off to Australia, the spatial data work stream. So that's a short introduction to today's presenters. I'll get them to introduce themselves as we go through as well, and I'm chairing the discussion later on. There is some mind mapping going on as well, which I'm interested to see what that involves, so we'll look at that later on. So what's today's agenda? Over the next 45 minutes, hopefully with Q&A at the end, we're going to look at an introduction to BIM and GIS, which is myself. Then we're going to move on to Martyn covering sharing data and how BIM and GIS work together in that process. And then also Darren's going to look at the end of it at how he's using BIM or GIS to fulfill a BIM workflow and how that fits together with a few worked examples. So let's start off the conversation going back to where we probably were many sort of 2008. You know, why are we doing BIM? Fundamentally, there's got to be a reason why we're doing BIM, and those are what I see the main 4 points. The benefit we've got to have is better performing landscapes. I work as a landscape architect, or used to, in a public sector. The biggest problem we used to have in the public sector would spend a fortune on the capital investment, and it would fall over in maintenance. Usually because of the handover process, because the budget wasn't set properly, the asset management wasn't considered properly. And really what BIM's trying to do is get better information to the asset managers to deliver what you as a designer wants to achieve. You have an idea and a sort of a concept that falls over usually in the maintenance, because the people maintaining your systems that you put into the ground don't know what your intent was. They don't know how it's got to be maintained, and they'll go along with the traditions they've always known. So part of this is trying to improve that whole process of moving from your design ideas into the maintenance and the operations of a project. So what we're trying to do is deliver better projects on time and to budget, and we want to improve sustainability carbon, and we want to do all this with cost-effective maintenance. How do we do that? If you look at any other industry in the world, the concept of virtual design and prototyping is just part of the process. There's no way that Boeing would ever go and sort of spend £50 million on a new aeroplane if they hadn't built it in the virtual world first, tested it in the virtual world first, then prototyped it, and then go and commission the build of it. You look at any other industry, the automotive industry, even the advertising industry now, will test different types of labelling, different types of ads, different colours, different techniques. Fashion industry are doing it all the time as well. So why do they do it? Because it reduces time to market, it reduces overspend, waste, it actually allows for the sort of breaking down of global barriers. You can just email somebody an idea, or even now, just connect and share that. With the ideas of 3D printing now, you can just print it off in front of you, have a look at it. But fundamentally, when we look at any other industry, it's all about that engenders this get it right first time mentality. Let's get it right in the virtual where it costs us very little compared to, I've just gone and spent £50,000 on this new flange, it doesn't fit this pipe. We've got to go and get some new flange, you've got to redesign it. So it's all about making sure that what we deliver in the virtual world works before we get into the real world. Now, if that works for other industry, why is construction anything different? Why do we in construction believe that we can do a 2D plan a 3D plan, some specifications, and we think it will work because of our experience. The reality is it doesn't, because that's why projects are usually overspent and over budget and over on time, because we get things wrong. What BIM's trying to do is actually trying to bring that notion of let's prototype it first, get it right in the virtual world before we go into the digital world. When we start talking about BIM, we've actually come down to 3 fundamental pillars. 2D drawings, that's a starting point. In some cases that will be enough. Manage 3D data. If the 3D visualization helps to make better decisions, it is BIM. Otherwise it's visualization. But more important, that's what we're going to talk about today, it's the information. It's the information that's king, because people can make good, valid decisions based on information. And what we're doing with a BIM situation, we're putting that into what's called a federated model. So you'll have different people producing their own little BIMs, 2D, managed 3D and data, and putting that into what's called a federated model, which is a combination of the architect's information, the engineer's information, the landscape architect's information to test that. That federated model gets worked into construction, and that moves into what's called the asset model, which is what the people who have to maintain your landscape need to deliver what you intended when you first planted that plant in the ground. When we start talking about BIM, we're looking to try and get a single truth, trying to get a representation that one object includes not only the graphical representation, 2D, elevation, 3D, but also the factual information about it, the information that describes it, which can be specification from a manufacturer. It can also be your design intent as well. So we're trying to move away from what's called a multiple representation or multiple points of reference to a single truth where we can output that in multiple different ways. And what we're really doing with BIM and CAD to some degree is we're graphically describing something. When we start looking at GIS, what we're really looking at is pulling together information that describes a feature where it exists in the real world. And that can be through photographic information, spatial data, which is effectively a CAD-based layout with polylines and lines and circles and things like that, and tabulated information, the elements that describe that feature. That pulls into effectively a melting pot where this information is geographically located. And that information then can be used as an analytical tool to inform the decision makers. And that's what GIS is brilliant at. It allows you to inform decision makers. We talked about BIM, about informing decision makers. That is where GIS becomes quite critical and quite important. And it's not new. If you think back to Capability Brown, he would do lovely plans, and he would locate on those plans plants, trees that would be planted in the real world. And he would describe them as woodland, parkland. Fundamentally, that got built. So fundamentally, as landscape architects, we've been positioning things where they're going to exist in the real world and describing them ever since day one. But we've never called it GIS, we've called it landscape plans or landscape master plans. But we're describing information that's going to be in place, and we can visualize that. And if you want to think about, if you had to go back to where GIS came from, or the modern thinking on GIS, there's a chap called Ian McHarg, who back in the 50s and 60s wrote a lot about the overlaying of data, which I know Martyn's going to talk about, and he was a landscape architect. So if you think that GIS is purely out of the domain of landscape architecture, modern thinking for it came from a landscape architect. And I often think about GIS really as getting information simply. I just need to know about something to get hold of it. Obviously there's ways of collecting that data. The old traditional ways of going out and mapping things out. Today, we're going to look at, I think Darren's got an example of a point cloud, which is all digitally collected from LiDAR data. But what that does is it informs our decision-making process. If we look at the comparisons between GIS and BIM, Effectively, GIS is graphical and database information that is currently describing what's there, or eventually will be there. And that's where BIM and CAD comes from, because we're actually designing things that will be there in the future. So it's still graphical, it's still database, it's still information. The only difference between CAD and GIS is really what is there, CAD is what will be there in the future. And when we start talking again about similarities, when you start looking at GIS, really all GIS is placeholders for information. And that placeholder information can be on 3 levels. One is point data, a physical tree or a bollard. It can be linear data, networks, which is a sort of a curb line or a fence line, which also includes point, because at the end of every fence panel you've got a node, which is a point, and polygons, effectively areas. And with GIS, the data is king, so the placeholders can be themed and coloured based on the question that's been asked. When we start looking at, I'm talking about BIM, but it could be CAD, really it's the geometry that describes the data. We tend to draw a tree that looks like a tree. In GIS, it doesn't need to look like a tree, it just needs to be a point to say that is a tree, and we can express it how we want to. When we start talking about CAD and GIS, CAD and BIM, usually we try and describe the object quite intensely graphical with 3D representations. What we're going to see with BIM coming over time is things called level of detail, where you may actually describe a tree as just a circle right the way through the BIM process. But again, CAD is usually point-based, linear-based, or polygon-based. As I said, GIS can inform design, because if you've got information in front of you, you can then use that design. So if you've got ecological importance, you can use that information as a design tool to take people through a landscape without affecting the sensitive areas. Generally, what you find with BIM is that you've got geographically or geometrically heavy models. So the data, the physical graphical data is quite heavy because we're showing walls, doors, trees, curbs. It's still data rich. When we start going to GIS, it's actually graphically light. It is just a point, it is just a line, it is just a polygon, but it's still data rich. The advantage that GIS gives you is it gives you that sort of ability to use the data to drive the output. And just to summarise how that works, if we look at an existing site, generally the existing site information is available in a database format. Where GIS is great is about to visualise that data. That visualisation can then inform the design model at the starting point. What's there, existing trees, existing vegetation, can go into the design model. Both the GIS data and the design data come into your BIM model, which is fundamentally and ideally database driven. And that then gets delivered to your operations managers. And usually operations managers prefer things that are quite lightweight, so it's all about database. So realistically, it's GIS again. And when we start looking at the two together, the key element between GIS, Geographic Information Systems, and BIM, Building Information Modelling, is that information. I know Martyn's going to labour on that a little bit later on in the next session. And where this will all come together is level 3. Level 3 BIM is what the government are preparing now, and that will be the Internet of Things and smart cities, and it will be working where things are in the real world, swapping them out, comparing them. It will be bringing together that BIM GIS technology in a smart, intelligent, data-rich model that can inform the decision makers to deliver better cities. If you do want to find more about Digital Britain or the Level 3, there is a document which is freely available, digitalbuiltbritain.com. And what I'm going to do now is hand over to Martyn to take on the next session, which is sharing data.
Thank you, Mike. So I'm assuming that the majority of people here today are landscape architects. I'd just like to get a brief hands up of those that are not landscape architects. How many here are from suppliers or manufacturers? Okay, good. Contractors and owners, projects? Okay, so mostly landscape architects and a couple of suppliers. So, as landscape architects, we recognise that there is a need to collaborate in order to get our schemes built. But whilst collaboration isn't new, within the construction industry, we're starting to be asked to deliver more and more of that information and data digitally. Now, in terms of the landscape architect within the construction industry, there are perhaps some additional challenges, and one of those perhaps is scale. I think this is where GIS and BIM link together to a greater degree. So from much larger scales down to smaller schemes, all of these can be managed through a digital design process. And then one of the other challenges we have is also the shift from rich graphical presentation to rich data, whilst at the same time maintaining that traditionally rich graphic presentation. So the images that you see here are all BIM-related projects, BIM projects where the data and the geometry behind it are linked together. It's not simply visual representation. So although the data can be used visually and will continue to do so, the important thing is that there is data behind those projects at the same time. Now, as Mike has already sort of alluded to, the similarities between GIS and BIM, they both have I in the name, and they both basically represent the word information. And what I'm going to talk a little bit more about is a subset of information, and that's the classification. So how do we break that information down, and how do we do that within a GIS context and also a BIM context, and how can we learn from that? So as Mike has already alluded to, I'll do this for sort of very quickly, but typical classifications for GIS might be the topographic layers, contour layers, basic coloured choropleth information there, and also real-world data and coordinates from that point of view. As you can see, this is taken information taken from the Ordnance Survey. And again, also as Mike's alluded to, you can break those classifications down into four main features within the GIS. So lines representing either rivers, boundaries or roads, points for particular objects, specific objects, whether that's trees or bollards, areas such as areas for planting, and also bodies of water, and then text. From a BIM point of view, on the left-hand side here, you can see maybe a sort of typical representation of what a BIM project would be. So we've got both the site and the three-dimensional model. And again, just to emphasize the point, the difference between that and a simple visual model is that you can, one, start to take sections and elevations that are live from that model, represented by the documents that you can see here, but also embedded in that model is data, and from that data you can create live reports that are associated to the model. So they are not separate silo entities. And then on the right you can see perhaps a sort of a more detailed sort of breakdown illustration of a sort of section here. And again, we're breaking the objects down into classifications of type. So we might have roads, planting areas, grassed areas, walkways, lighting. So these are types of classification that we typically see within a BIM model. And again, to reiterate the point, this might, maybe sort of 10 years ago, have been simply a visualization model that was created separately from the documentation drawings. But you probably recognize this site as being ground zero here by Peter Walker Partnership. that is a BIM model. So the geometry created also creates the more schematic plan views, but also, importantly, the data is embedded in those objects and live reports can be taken out from those. So we're starting to see some of the similarities between the GIS, the associative data that is used within the model data sets. So the next question might be, well, how can one single data set deliver those different outputs? The simple answer to that is that it's in the software. The technology has developed from the software point of view so that we're no longer dealing with just simple lines or arcs and text. So we're not simply replicating an electronic drawing board, but we're developing intelligent software that enables those different links to be made to both the geometry and also the alphanumeric data. So again, the information is the same. I can change the data in one and it will have an impact on either the geometry, or I can change the geometry and it will have an impact on the data. And again, that doesn't matter whether it's a larger site, as you saw before, or a municipal flower bed or planting area. And so the question then starts to be asked is, well, can we start to integrate those? We can see that there are links between the two different systems, not least the I in the two names, but can we start to integrate the two different types of models? And here's an example of photographic information, basically taken from GIS data and information and models, and started to be imported through into BIM authoring software. And there are common formats that can be shared, and that's a very important theme for us to try and discuss and develop. So here we have the topographical levels and contours being taken through, the building outlines coming from the GIS data and being taken through into the BIM authoring software. And three examples here of the same data, again, coming from the GIS. The data is embedded, it's attached to the objects, and so therefore, when we talk about analysis, we can start to take that data, but then visualize that data in multiple different ways to be more communicative and also maintain that rich graphical tradition that we've got. So here we have the data being interpreted in different ways, identifying specific buildings, identifying different building types within the same model, and then identifying the green areas and specific existing trees, for example. So let's take a little bit of a deeper look in terms of how the information is organised, particularly from a BIM point of view, and in particular in regarding the British standards. So this is the page that talks about how data is delivered or projects are delivered within the government construction strategy. I make no apologies for the fact that this is obviously a building here. It's what was chosen. We make great emphasis on the fact that building is not a noun, it's a verb. So exactly the same principles apply within the landscape arena. Again, we have a model. From that model, we can take construction documentation from our traditional sort of 2D output, but also we can take the data as well. Now, the data that you see, so particularly perhaps lurid colours being used. This is a COBE data deliverable, which is within the BIM Level 2 mandate. So if you're asked to comply with the BIM Level 2 mandate, you may well be asked to output this particular format of data. Let's just take a step back and just break the data pipeline down into three simple, distinct areas. You perhaps now understand why I was asking who's here. So we have really data input, data use and analysis, and then data output. And within that, we can put that into supplier, the consultant, whether that's a landscape architect, the architect, or structural engineering through to the scheme owner. And if we take a look at the information model, you'll recognise this image from before. We have a number of initiatives in terms of how we're sharing that data. So within the UK, the initiative for data input that is coming from manufacturer and suppliers is known as PDTs or PDSs, Product Data Templates and Product Data Sheets. So that is the information going into the model, and then out of there we have the information required for maintenance. The scheme for the data output is known as COBE, as I said, and that stands for Constructors and Operators of Buildings Information Exchange. I don't come up with the acronyms. There are lots within the industry. Obviously, the fact that we're talking about GIS and BIM sort of alludes to that fact. But essentially, the product data sheets is an initiative to create common templates that suppliers of associated products can use to create standard forms of information so that the consultants, you guys in the main, do not have to input that information manually each project that you're doing. So there's a common standard of information that's coming in. That then links to the common standards of information being delivered out. So again, if we can create common standards, then we know if a client is asking for a particular type of information output, if it corresponds to COBE, which is the main one at present, then that makes it easier and more efficient for everybody involved when they're taking the information through the pipeline. Just to give you a couple of examples, again, here are the spreadsheets. You'll see there's a common theme to the colour here. But the important thing is these are data sets, and they are associated with the intelligent models that are being created. So within the BIM context, here's space or zones, and that would correspond to the zones and areas within the landscape scheme itself. So it is transferable, and it's cross-industry and cross-sector. Another type of output or of the deliverable is actually type. I talked about this before, and again, this is relating to the specific types of objects that you find within the scheme, and this would be used at the early stages for early cost analysis, etc. Now, these are the sorts of outputs and deliverables that you do already in one form or other. This is simply a way of formalizing that and ensure it's delivered in a digital content. And going down then to components. So an example might be, we've talked about it already today, existing trees. That's a specific type of object, but you might want a report out or analysis certainly of the specific components, the specific existing trees within that scheme. You already perhaps import tree surveys. They can be used to generate the models directly. Okay, a few more slides and then I'll pass over to Darren. But what I wanted to just show, unfortunately the resolution on here is not coming up as on the projector as it is on here, but this again is a set of, if you can make it out, a set of building outlines taken directly from GIS data. So importing the data is not just simply a case of importing the graphical information. Over the right-hand side, again, the resolution is probably not showing for you guys, is the data that is assigned, the information that's assigned to those GIS data. And again, common formats to import in, but the important thing is that although a lot of the GIS data is purely two-dimensional, we talked about the representation of points and lines and rectangles, because it has data in such as elevations and heights, then that information can be interpreted into a BIM authoring software as three-dimensional data, and so then you can basically carry on down the pipeline. So this is an example of buildings, and exactly the same thing here in terms of existing tree survey being interpreted into, at this point, a low level of information in terms of level of detail. But again, within the BIM model, you have an option of how to control that graphical output throughout the process. So I think that's my time up, and hopefully that leads and segues quite nicely into Darren's part of the talk.
Cheers, Martyn. Yeah, I'm going to spend the next 14 and a half minutes talking to you about sort of real-world applications of actually sort of using the GIS to actually facilitate BIM workflows. And this is some of the work I've been doing at Arup for the last 5 or 6 years. Because even though I think on the previous slide it says I'm a BIM manager, on some jobs I get touted as BIM manager, on some jobs I'm information manager, some jobs I'm a GIS manager. Essentially what I do is I deal in information, and it's generally graphical information as well, but behind the graphics, as Martyn said, there is an awful lot of data, and it's the data that is my concern. And my main job is to actually develop tools and workflows that can actually facilitate the actual delivery of projects with enough information to give clients all the information they need to actually make decisions at certain points. Key to all of these are sort of a couple of documents like the employer's information requirements and BIM execution plans. BIM execution plans are probably one of the least exciting documents you're ever likely to read, and they're probably even less exciting to write, but they're incredibly important because they set out absolutely everything you need to know to actually be able to deliver a project digitally. It maps out who's going to be given what information to who, when they're going to give it, how they're going to give it, what they need it for. Now, everything you need to know to be able to deliver the project is in these documents, and without them, we can't really do BIM, to be honest with you. The project I'm going to talk about is a particular botanical garden in the Middle East. And it was an incredibly different project from anything I've ever worked on before, because the graphics on here aren't very good, are they? But anyway, sorry, I digress. It was different in as much that the plants that were going to be used in this garden are already actually being grown, and we was estimating there was going to be about 400,000 plants across the scheme. And there were 23 different separate habitats across the entire scheme. We were given this master data set by the botanists who are actually at the moment out in the wilds collecting seeds, growing the plants from the seeds to actually be used within the garden. And within this data set we had nearly 3,500 rows of data spread across 38 columns, and in those columns everything you needed to know about that plant as to like who picked it, where they collected the seed from, how the plant was germinated, everything that's gone through from the day the plant was picked to it actually gets put in the garden is recorded in this. And the stipulation of the client when we was writing the BIM execution plan was we want every plant to come back to us in a data set with that data attached to it. So that then to the problem where the traditional ways of going about this wasn't going to be suitable. And we also had to make sure that what the designers were designing was actually being grown, so that the designers weren't planting 10,000 of one species when they've only actually managed to actually grow two plants. So it had to be trackable back to the nursery. We also had to produce a set of drawing plans or planting plans, and there was over 600 planting plans for the site. We also had to ensure that what we were doing with our planting was actually usable for clash rendition. The final data set had to be used by the facilities management team, and the interpretation team wanted a data set that they could use for some augmented reality at the end of it. So it really did only leave one option, and that was to actually sort of go down the route of GIS. But it was GIS, but being done in a sort of a BIM process deliverable way. So what the first thing we did was we actually had to split the site up into zones to actually make it a manageable thing. And by splitting it up into zones, we was actually be able to create a single data set with, I think it was like 32 feature classes within that data set. So it meant that 32 individual people could work on the same data set at the same time, if necessary. So we was actually able to bring in individual areas and people could work on it as point data. And what we tried to do was try to make it as human-proof as possible, but we didn't give the people any choice in what plants were going where, because plants for certain habitats had to go in that habitat. They couldn't be used anywhere else, and vice versa. So we actually we actually set up things that are called like domains that would then, there was a list that was restricted so that the user could actually only use, or in a certain habitat, was only actually able to use a certain plant, and that was done via a drop-down menu. So it meant that the user didn't have to worry about anything else other than just choosing an abbreviation. They didn't have to worry about filling in reams and reams and reams and reams of data for each individual plant. And also the system that we used What was really important in this entire scheme, absolutely everything was designed by hand originally. The project managers on the project decided there was no way they wanted to see 20 landscape architects that sat there at a computer all day long pushing a mouse button. They wanted to see people with pen and paper, which was great for us as from the technical delivery team, because we was able to take their hand-drawn designs, bring them into sort of geo-reference them into our GIS environment, set up our GIS feature classes to actually match these pretty pictures. So, and then all we had to, we didn't even need to know what the plants were. All we had to do was go, it's a round pink circle with a yellow line around it. I know, just copy and paste 20 of those on top of the planting plan. And it seemed really basic, and it is really basic. I had 5 technicians working solidly for 2 weeks, and they delivered 400,000 plants in those 2 weeks. And it meant it freed the designers up to do what they do best, which is design. The technicians did what they do best, which is to push buttons. They didn't thank me for it, and they weren't exactly thrilled by the end of the 2 weeks. But they did get fed a load of beer, so it all worked out all right in the end. But the important thing is, at the end of it all, what we were left with was, this is just one tiny little area of the site. There was 32 of these, a feature class that's just purely had nothing but abbreviations for all of the plants that are in there. And what we then had to do was, that's the abbreviations. Then what we did, we took that data into a piece of software that's it's called FME, and it's like the daddy of all GIS translation tools. It translates sort of 400 or 500 different formats of data. And there's 700 translation tools that you can do stuff with it, and then you spit data out the other end. It's a geek's dream, it really is. But what we was able to do was take the single column of data that we had from the data, join it with the master spreadsheet that I showed you on the first couple of screens, and then what you end up with is a really, really rich data set. So that what started off as abbreviations now contains all the species. It contains, quite importantly, where it is. It's Eastings and Northings. It's ultimate canopy size. It's the size of the tree pit that's needed. It's water content. It's how much water that plant's going to need over its lifetime, or for the irrigation consultants. So once we had that data, this is when it actually becomes quite fun from my point of view, because we've got a huge, quite big data set, and it contains loads and loads and loads and loads of information. And what we can do, I can't even read this, so I'm not entirely sure that you can. No, but I'm pretty sure that's the type and the canopy. What we're able to do is take this back into that the FME software, and just completely straight away actually output AutoCAD attributed blocks that contain the data that the irrigation consultant needed, because the irrigation consultant, as part of the BIM execution plan, said that he needed to know X, Y, Z, and this to be able to run it through his software. So that was a deliverable to the irrigation consultant. And then from there, we was actually able to take more of the data and again take it through this FME workbench, and essentially produce an awful lot more rich outputs from it. So we've delivered AutoCAD blocks first off with which could be used for the irrigation consultant. We then wanted to produce all the planting plans. I'm really disappointed with these graphics, but so from this, we was actually able to export the data from the GIS and produce a series of X-reference files that will go into AutoCAD that would feed the 500 planting plan drawings, and they were split by types and different locations without the site. But essentially, 600 drawings were generated automatically without any human input whatsoever. Not once did we have to go into any of these drawings and manually alter them. It was all done from the workbench that I showed you just a minute ago. So that straight away, the time savings on that, just from using sort of a BIM workflow on a single source of data, was phenomenal. Secondly, the next one was we also had a requirement to produce the soil drawings, and from that single set of data, because we knew each plant had an attribute that would say how big the soil, the tree pit was. We also had data in the background that would describe the depth of the soil, so the build-up of what each plant needed. So it would actually then we would run it through run it through that workbench, and out would pop a not just a soils model, it would actually calculate the quantity of different types of soil that were going to be needed throughout the entire project. And again, that was all just derived from the single set of data. We also was able to produce all the schedules from the data. That's quite a simple one. And if you've got the schedule in we was also actually to be able to split those schedules up into habitat areas as well. So we had a requirement to deliver by habitat, so we was easily able to, as it went through the transformer, completely split it up into what we needed to be able to deliver. And importantly, as I said at the beginning, each one of these trees or each one of these plants at the moment is being grown specifically for this garden. And we needed to make sure that there was a tag back to as these things went through the transformer, it was assigned an ID number, and then that went back to the nursery, and then they started putting tags onto the plants. And it was at that point, and then we was actually able to go into our drawings and actually decide where, or go into our GIS data and actually decide which of these trees were going in certain locations. So and this sort of constant sort of backwards and forwards tagging between what's going on in our design and what's going on in the nursery is still going on now. We also had a requirement as part of the BIM execution plan was we didn't have to deliver to the client because the client didn't want a 3D model of the planting. The client wanted this data set. But we was also working with sort of our third-party consultants and our sub-consultants who were the architects on the biomes. They demanded a Revit model, and at first we were saying, well, there's no way we're going to do our planting in Revit, it's being done in GIS. But to meet them halfway, what we did eventually do was start developing some scripts within Dynamo, which is like a halfway house between Dynamo, between sort of other platforms and Revit. It's a really good way of shoehorning stuff into Revit. So we spent quite a while actually sort of investigating and actually developing these scripts, and we was actually able to get it to the point where we could read the GIS information, bring it in, create the family, give it all the attributes it needed, and then bring it into a model. So then we was actually able to deliver to the architects a fully attributed 3D model of the different habitats that they required for the thing. But what was also good from that, because we'd done that, was also then able to bring that into something like Navisworks and with the tree pits as well, actually be able to do really quite good clash detection. And the last little bit, which is, I think this stuff's phenomenal. This is a piece of software called InfoWorks that just reads absolutely everything. You can just bring any format into it and it's reading it. So we was actually able to bring together a central model of all of our earthworks that were going on, all of the architectural elements of the site that was going on, and all of our planting. But we never actually had to do anything. We just referenced it into this model. So individually. So all of these trees that are in this model are being read directly from our data set. There's no import, there's no export. It's just directly reading the data. And with some clever styling, we can almost get the trees to look almost like what they're going to on site. That bit's quite difficult because some of these trees are a bit different than the normal trees. But anyway, it was quite a good tool to actually give to our designers. As we were plotting the plants, they could see what was going on in 3D. And the final bit is we're also going to be using this single data set to actually monitor the works on site. So we've hooked it up to like a web app, which is linked to like a handheld device. So as plants are planted on site, we can monitor that in fact the right plant has been planted and it's in the right place. And if it's not, it can be recorded on the handheld, sent back to the online app, which will automatically update the single source of data. So the thing I'm sort of I think the main sort of gist of what I've been trying to say is that the outputs that we got from the data are quite diverse because they needed to be, but they needed to be because we sat down at the start of the process and sat down with everybody and worked out what it was that people wanted. What did they need it for? When did they need it? How did they need it? And once we got that with the BIM execution plan in place and we had a really good idea, a clear idea and a clear map of what we were going to do, it was then we was actually able to start actually designing, developing the tools to actually enable and to facilitate those workflows to happen. It's still an ongoing project, so it's this set of data that I'm talking about is still there and it's still a live set of data. Hopefully it won't change too much because I still haven't got those 5 technicians anymore. But we've the fact is the data's there, and as Martyn said, data is king. And now we've got the data, we can do whatever we want with it. So if anyone's got any other ideas of what to do with data, give me a shout because I'll listen to it. I think that just about wraps up what I've got to say. I think Mike's going to take over and lead the discussion and questions and answers.